Welcome back, everyone. Moving on to the next video, we have another limit to solve. So we got the limit as x approaches 1 over 4 of 4x minus 1 all over the absolute value of 4x squared minus x. So we actually have to graph this function first and then find the limit. And this one's going to be a little bit more complex than the other functions that we've dealt with that had an absolute value, the other one-sided limits. There's going to be a little bit more going on here, but I'm going to do my best to try to explain it. So first thing I like to do when I see something like this is I actually like to simplify it. And notice that in the denominator, we can actually factor out an x within that absolute value. So notice that an x is common to both of these terms. So if we take out an x, we'd end up with 4x minus 1 in brackets. And remember, that's still all within that absolute value. And whenever you have something like this, notice we're multiplying two things within an absolute value. Whenever you're multiplying two things within an absolute value, then you could just split that absolute value into both of those elements, or however many elements you are working with. So if you got the absolute value of AB, that's going to equal to the absolute value of A times the absolute value of B. And so if I use this rule here, notice we could split up that x. That has to be within an absolute value though. And then I could split up this 4x minus 1 as well. Okay, so this and this are the exact same function. And I feel like it's better to work with this because now we can kind of see more what's going on. So one thing I want to mention here is that notice that there's two x values that are going to make the denominator equal to 0. Notice that an x value of 0 would make this denominator 0, because if we plug in 0 here, this whole thing would be 0. If we plug in 0 here, we'll have the absolute value of -1, which ends up being +1, and then +1 times 0 just gives us 0. So at an x value of 0, the denominator is 0 of this function. You can see that if you plug in 0 for x here as well. And then also with this factor, notice at an x value of 1 over 4, the denominator would be 0, because that means that this whole expression is going to be 0. So if we have 4x minus 1, when does that equal 0? If we isolate for x, it's going to happen at 1 over 4. However, this is pretty important. Even though both of these x values are making the denominator 0, if you remember from advanced functions, the reasons why, or how it's going to look graphically, is going to be different. Notice that at this x value of 0, what's the numerator going to be? The numerator is going to be -1. So what we'll end up having is -1 over 0. And whenever within a function you have some kind of number over 0, that means that that's going to be a vertical asymptote for the function. But notice at the x value of 1 over 4, the numerator is going to be 0 and the denominator is going to be 0 as well. And whenever you have that, that means that at that x value, there's going to be a hole. So notice that both of those factors would cancel out at that x value of 1 over 4. Okay, so that's a pretty important distinction. And the reason why I wanted to make it is because notice that we're finding the limit as x approaches 1 over 4. So we're more concerned about what's going on with the function around this x value. Because there's multiple absolute values in this function and you want to turn it into a piecewise function, which is what we're going to do, you can make the piecewise function more complex because you have this absolute value of x as well. So you can make it for x values less than 0, between 0 and 1 over 4, and then for x values greater than 1 over 4. But because for the limit, we're looking for what's happening with the function around that x value of 1 over 4, the piecewise function, I'm only going to deal with two pieces, when the function is greater than 1 over 4 and less than 1 over 4. And so I'm going to show you how to do that now. I'm going to take this actually, just in case I need more room. I'll write it up here. Okay, so let's turn this function into a piecewise function. So we got this absolute value of 4x minus 1. And if we follow the same process that we've been following, how do we turn this into a piecewise function? Well, if 4x minus 1, if that expression within the absolute value is going to be greater than 0, if it's going to be positive, then we're just going to keep it. Because remember, an absolute value is taking anything negative turning into a positive. But if it's already positive, then we just keep it how it is. But if that expression within the absolute value is going to be less than 0, if it's going to be negative, then we have to take that expression, 4x minus 1, and multiply it by -1 in order to turn it positive. Right? So this is basically equal to that. And if we, you know what, let's just keep it like that for now. And so using that over here, basically what we could do is we could take this and simplify it to 4x minus 1, that numerator staying the same, absolute value of x, that's staying the same, and this is going to be positive 4x minus 1. This, right, when 4x minus 1 is greater than 0. And then we're going to have 4x minus 1 over absolute value of x, and then we'll have a negative. Let's put this in a square bracket. Like that. When this 4x minus 1 is less than 0. When it's negative, we're going to be multiplying it by -1. So I just took this and put it here. The reason why I put it in a square bracket is because I don't want you to think that it's absolute value of x minus this. Okay, it's absolute value of x times -1 times that. And so if we simplify this, notice we could simplify because this and this cancel out. And so what we're going to be left with is we're going to be left with 1 over the absolute value of x. And that's going to happen if we isolate for the x here. That's going to happen when x is greater than 1 over 4. And then notice here the 4x minus 1 cancels out. So we got this -1 here. So this -1 we could even bring up top. So this portion is going to be -1 over absolute value of x. And that's going to happen if we isolate for the x here in this inequality. That's going to happen when x is less than 1 over 4. Right? So pretty much the same process as we've been doing before. It's just now that we have this absolute value of x within the piecewise function. And we can create another piecewise function for this absolute value, but I'm actually just going to leave it like this for now. Where should I do this? Actually, let's just do it here. So 1 over x, this graph here, we know that it looks like this. That's 1 over x, right? The parent function, the parent reciprocal function. So if we know that, how is 1 over absolute value x going to look? How is that graph going to look like compared to this one? Well, notice that this portion is going to be the same because all those, all the y values there, all the x values are positive, and so it's just going to stay 1 over x. But notice if the x values are negative, it's going to take all those negative x values and turn them positive. So what's going to happen is we're going to take this leg here and we're actually going to flip it. We're going to reflect it so it's positive. And so it's going to end up looking like this here. Right? So basically this notice that this is always going to be positive because you're always going to have 1 divided by a positive number. So all the x values, when the x values are negative, so let's say it's like -2, it's going to end up being +2. So we'll have 1 over 2. So all the y values are going to be positive. So all these negative y values, we basically reflected up there. Okay, so that's how this graph looks like. And then -1 over absolute value x. Notice it's just going to be this graph, but reflected. So it's actually going to look like this. Notice that all the y values for this function are always going to be negative because the denominator is always going to be positive, but then we're going to have -1 divided by a positive number always, which is always going to give us a negative number. So all the y values are going to be negative. So that's how those two functions look like. Right? Thought I would mention that. And so now we can graph it. So knowing that, having that written out, when x is greater than 1 over 4, then we have 1 over absolute value x. And 1 over absolute value x, we know that it looks like this. But let's actually put this x value here. So this is 1 over 4. Now, if we plug in 1 over 4 here, we're going to have 1 divided by 1 over 4, which is going to give us +4. So we know at an x value of 1 over 4, we're going to have a y value of +4. And notice that this function is only defined when x is greater than 1 over 4. So we actually don't need this portion. And we actually don't need the portion up to, you know what, let's bring this y value down a bit. So here, that's where the y value is. That's going to be +4. We don't need this part. Right? All the stuff that's less than 1 over 4. So I had the whole function drawn out, but then I erased everything that was less than 1 over 4. All the x values that were less than that x value 1 over 4. And notice that it's greater than 1 over 4. It's not greater than or equal to 1 over 4. So this here is actually going to be a whole, like that. Right? So that's how this piece looks like. And then when x is less than 1 over 4, it's going to be -1 over absolute value x. And as I showed you before, -1 over absolute value x looks like, let me give myself some room here. So this is 1 over 4. It's going to look like this. Okay, and if we plug in that x value 1 over 4 here, we're going to have -1 over +1 over 4, or -1 over 0.25. And that's going to equal -4. So this, it's going to be -4 there. And notice that this function is defined for all the x values that are less than 1 over 4. So all the x values that are greater than 1 over 4, I'm going to erase. And over here, notice it's not defined at 1 over 4. So there's going to be a hole there. Right? Perhaps not the best drawing, but that's how this looks like. If you actually take this, plug it into Desmos, you should end up getting this, this function right here. And notice at that x value 1 over 4, it's not defined. That's why I don't have an x equals 1 over 4. We could put an x equals 1 over 4 here, but we would just put undefined over here. Because remember, at that x value 1 over 4, it's going to be a whole, right? Because the numerator, as we mentioned, is going to be 0, and the denominator is going to be 0. Right? So to graph it, what we did was we took this, converted it to this piecewise function, and then this piecewise function we graphed over here. And just dealing with that absolute value x, is a little bit more of an extra headache, but it's actually not too bad when you think about how it relates to that 1 over x, that regular parent reciprocal function. So that's the graph, and now that we have the graph, we can actually find this limit. So notice the limit as x approaches 1 over 4, I'm going to let this function equal f of x. So you could write out the function here. I'm just going to write f of x. The limit as x approaches 1 over 4 from the negative side, what's that going to equal? Notice if we're approaching this 1 over 4 from the negative side, the y value is approaching negative 4. So as x approaches 1 over 4 from the negative side, the y value is approaching negative 4. So this is going to be negative 4. And then the limit as x approaches 1 over 4 from the positive side, we got to look at this piece over here. The y values are approaching positive 4. And because they're approaching different y values from both sides, from the negative side it's approaching negative 4, from the positive side it's approaching from the negative side it's approaching negative 4, from the positive side it's approaching positive 4. That means that this limit, the general limit as x approaches 1 over 4, I'm going to just rewrite this function, 4x minus 1 over 4x squared minus x. It means that this limit does not exist, right? Because those one-sided limits are approaching different y values. If they were both approaching the same y value, then this limit would just equal that y value. But because the y values are different, that limit does not exist.